Hi, it's Michael again, and you are watching the follow-up to my previous video I uploaded about synthesis of copper nanoparticles to be applied to PPE. So it turns out there's a lot of research about nanoparticles going back over 100 years. It's just they've become trendy now, like HD. First it was just TVs, now everything's HD. I think there's an HD lawnmower even. Anyway, I read several research papers and studies. The trend nowadays is to get away from more costly or complicated syntheses like laser ablation and thermal decomposition to wet chemistry methods, which are much simpler and easier to do. Even I can do them. And so I recreated several of the experiments and documented this one here. So without any further ado, let's go. So there's several wet chemistry methods for synthesizing the nanoparticles. All of them involve reduction of copper salt in the presence of a capping agent to control size and dispersion. Today I'm going to be doing the same reaction I did in the first video, which is the reduction of copper sulfate by ascorbic acid. The capping agent is povidone, which is a binder used in the pharmaceutical industry to make pills, for instance. Now, my yoga instructor said I should only use the non-GMO vitamin C. And I said, hey, but isn't heroin, cocaine, and snake venom non-GMO too? But she didn't think they'd make good electron donors in redox reactions, so better stick with the ascorbic acid. One of the studies I read used gelatin as the capping agent, which I think they hydrolyzed to form long-chain amino acids and polypeptides. Basically, these capping agents are any kind of long-chain polymer that surround the copper ions in solution and affect their dispersion and size, which can range anywhere from a few up to 100 nanometers in diameter. Another variable is substituting ethylene glycol for water as the reaction solvent. This can speed up the reaction and reduce the time from 8 hours down to 1 hour, because it also acts as a reducing agent for the copper salt. You can use all kinds of different reducing agents. Sodium hydroxide was suggested in some of the studies. I know what you're saying, it's not non-GMO, but it's used in such minuscule concentrations like millimolar concentrations, which is almost like homeopathy. So I doubt it'll melt your face off. You can also use it to control the pH of the reaction solution along with sulfuric acid. Some of the studies suggest a neutral pH around 7 makes the smallest particles. So, yeah. And then, of course, today we're going to just use the distilled water as the solvent. And that's it as far as reagents. The apparatus consists of a hot plate stirrer, round bottom flask with a thermocouple adapter as the reaction vessel, and an Allen condenser configured as a reflux column to minimize solvent evaporation. Okie dokie, so we'll start with making our stock solutions. Now, you could make stock solutions with all the reagents, but the ascorbic acid and povidone can just be added dry and dissolved in the reaction mixture, so we'll just do the copper sulfate. We're going to make 250 mils of a 0.04 molar solution. I'm using copper sulfate pentahydrate, which has a molar mass somewhere around 249 or 250 grams per mole. So, according to my calculations, we're going to need about 2.5 grams. So we'll go ahead and weigh that out. Yeah, it's exciting, isn't it? Damn, this guy's good. And we'll add that to a volumetric flask with some distilled water in it. And then shake till dissolved. Now here's an important safety tip, kids. These copper sulfate pentahydrate crystals take forever and a day to dissolve, so I would recommend grinding them up into like a finer powder before you try this at home. And once it is finally all dissolved, fill to the mark. Now another important safety tip, when you store your solutions, make sure you label them so that you don't accidentally drink them with the popcorn while watching Netflix. And there we go. Next we'll figure out our reaction solution. The volume of the solution is arbitrary. Just depends on how much product you want at the end, as are the absolute concentrations of the reagents. What's important is the mole ratios of copper 2 plus ions to the reducing agent as well as the capping agent. So it's best to start out with the copper salt and determine the number of moles you'll have in solution. I'm using 100 milliliters of the stock solution, so that'll give us 4 millimoles. And from that you can determine the amount of ascorbic acid. The studies ranged anywhere from a 4 up to 100 to 1 ratio. I'm using 20, so that will require 14.09 grams of ascorbic acid. You do the same thing with the capping agent. These ranged from less than 1 up to about a 9 to 1 ratio. The more, the higher the ratio of the capping agent, the smaller the particles are. And with the reducing agent, the ascorbic acid, the smaller the ratio there also gives smaller particles. So to recap, we're going to use 100 milliliters of the stock copper sulfate solution, 14.09 grams of ascorbic acid, and 24 grams of the povidone. Start by measuring out 100 milliliters of the stock copper sulfate solution, and then add that to the round bottom flask. Next, add the povidone. Now, if you thought the copper sulfate was bad, this stuff is like a nightmare. It dissolves extremely slowly. It forms like this giant glob that I wound up having to fight with a stick for about an hour. So it's actually best to do this in a separate beaker beforehand. You could heat it up a little bit and not have to pull your hair out. Also add it in small amounts, otherwise the glob gets big and dissolves even slower. It will eventually dissolve though, and And then the last thing you'll want to do is add the ascorbic acid. Once everything's added, rinse out the neck and you're ready to start. Start the stirring and the heating. The mixture needs to be heated to 80 degrees Celsius or centigrade if you're from that part of town. You also want to check the reflux column and make sure it's not flooding. Now, while some of the reactions I researched occur instantaneously, unfortunately this is not one of them. It needs to be held at 80 degrees C for 8 hours with constant stirring. The reaction mixture undergoes a color change during that time, starting out as a light blue and progressing toward a brick red, which gets darker and darker toward the end. It's also a good time for you to catch up on all those things you've been procrastinating on around the house. So here's what it should look like when it's finished. Next we'll transfer it to a graduated cylinder so we can measure the amount of product. This is also a good time to record your audition for those stock footage reels of people pipetting in those news segments about medical technology. Alright, let's see what we got here. About 147. Here's what the product should look like. It should be clear, not cloudy, and there should be no precipitate at the bottom, and it should stay this way indefinitely. So the last thing we need to calculate is the copper concentration, and we do that from the starting amount of copper 2 plus, the volume of the final product, and the molecular mass of copper, which here is about 1,729 parts per million. Let me just double check that. Another thing you'll need to do before testing and using the product is to dilute it down to some sensible concentration. The papers I read used anywhere between 10 to 30 parts per million to test it against bacteria and fungus. So I'm going to go ahead and dilute this product 25 to 1 with distilled water. And that'll serve as kind of a stock solution for testing. The diluted product, if effective, could then be spray applied onto PPE. If you want to make the big bucks, you should probably use a car wash and a pallet of masks. Oh yeah, look at them Corona monsters run.